Dear Level 3 students, credit our system, Department of Socio-Computing at the Faculty of Economics and Political Science, Cairo University. Welcome back to our course named Social Network Analysis. Lecture 11. Let's start with a brief review of what we have studied in the previous lectures all over the semester till now. In the first lecture, we studied the concept of complex system, and in this regard, we discussed together what is a system, and we said that a system is a set of interrelated components. And from this brief definition, we studied many examples of systems in our social life, and we say that all the systems existing in our social lives are examples or can be considered as examples of system because all of them are composed of many components, and these components are interrelated together with relationships or ties. And then in lecture 2 we studied the complexity of social phenomena. We first define what complexity mean, and then we try to understand the complex nature of social phenomena, and we represented social phenomena as a complex adaptive system. Social phenomena in general includes people and organizations and institutions interacting together. Many people and many organizations and many institutions, each has its own properties and its own attributes and its own way of communication. All these components are interrelated together. There are relationships or rules governing their attitude and their actions and their relationships. So any social phenomena can be analyzed and viewed as a complex adaptive system. So in the first two lectures, we studied complexity, complex systems, complex adaptive system, and then we applied these concepts to social phenomena in order to prove that social phenomena is an example of a complex adaptive system. So why do we study this in social network analysis course? In lecture 3, we defined a social network as a social structure made up of individuals and organizations which called nodes. These individuals or organizations and these nodes are connected together by one or more specific types of ties, and these ties are called edges. And then behind each complex system there is a network, because by definition a complex system is a set of interrelated components, and a network is a set of interrelated nodes, and these nodes are interrelated or connected together through edges. So social phenomena in general as a complex system, as I previously discussed, it's all about a network, a big network or a huge network. And from this, we can say that we live in a networked society, and in lecture 3 we discussed many examples of what we mean by networked society. In lecture 4, we start to study some of the general attributes or properties of networks in general. And as you know, networks is decomposed into nodes and links, or nodes and edges. So we will start first by studying the general network properties, and then we will start to study properties of nodes and then properties of edges. So in lecture 4 we studied general network properties. Like what? We studied network size, and we said that network size is the number of components inside this network or constituting this network. So if a network is constituted of, say, 10 nodes, and these nodes are interrelated, then the size of the network is 10. And then we followed and discussed another concept of networks or general network property, which is the direction. And when we say that networks are classified into directed and undirected network, and then we moved on to how to represent network or mathematically represent network or computationally represent network to the computer further on. So network representation may be applied by three different methods. We studied adjacency matrix, and then we studied links list, and we studied also adjacency list, and we took an example on how to represent a network using these three different ways of representation. In lecture 5, we continued to study the general properties of social networks or general network properties, and in this lecture we studied network degree, and we studied network degree in both directed and undirected networks, and then we studied degree distributions, and you made an exercise with the teaching assistant in the section on degree distribution. As we discussed in the previous slide, a network is composed of nodes and edges. So we studied in lectures 4 and 5 the general network's properties, some of the general network properties, and then we will move now in lecture 6 to study edges properties. In lecture 6 we studied some of the properties of edges like the weights. In some networks edges are weighted, so if edges are weighted, then we say that we have a weighted network, and when edges are unweighted, they don't have weights, we say that we have unweighted networks. So we have weighted and unweighted edges, which leads me to weighted and unweighted networks. And from the weighted and unweighted networks, we studied traffic networks, because traffic networks is one example of weighted networks. And we say that traffic networks is very important because, for example, the example that we studied in lecture 6 is internet. Internet is a traffic network because data goes on from one node to another. But the data, the quantity of data that goes from or travels from one node to another through the edge between these two nodes is not the same. So here the weights of the edges will be the quantity of data transferred or traveling from one node to another through this edge or through this link. And from traffic networks, we moved also to another application of edge properties, which is paths. And we say that paths are like the journey from one node to another. In order to proceed or to move from one node to another, you should have a path, and this path may take just one step from node 1 to node 2, but if I want to go from node 1 to node 4, for example, so I have first to pass by 3 edges, which is the edge between node 1 and 2, and the edge between node 2 and 3, and the edge between node 3 and 4. So from the path concept, we moved to the path length, which is the number of steps or the number of edges you have to pass by in order to move from one node to another. So path and path length are two properties that can be calculated using the edges of the network. So we are still studying edges properties, but from path length we move to another very important concept, which is the shortest path. Shortest path means that we find all possible passes between any two nodes, and then we find the shortest path, which is the least number of edges that can be covered in order to transfer or to travel from one node to another. In lecture 7, we started the first part of nodes properties, and in lecture 7 we discussed a very important concept also, which is capturing centrality. Centrality is one of the most important concepts in social networks because centrality gives me an impression or gives me a record on which node of the inside this network is the most important node or the most central node or the most influential node. So in order to capture centrality, we have many measures. It's not just one measure in order to capture centrality. And in lecture 7, we studied 3 different measures. We studied degree centrality, betweenness centrality, and eigenvector centrality. And degree centrality is for undirected networks, while for directed networks, we studied in degree and out degree centrality. So we have 5 measures in this lecture: degree centrality for undirected networks, in degree centrality and out degree centrality for directed networks, and then we studied betweenness centrality, which is another totally different notion of centrality, and then we studied eigenvector centrality. In lecture 8, we continued to study other nodes properties. In lecture 8, we studied network connectedness, and we say that there are some nodes in the networks. They are very central, because these nodes, if omitted from the network will be disconnected. And disconnected networks create what we call network components. Sometimes the network, it's not all over. Sometimes the overall network is not in just one component. Sometimes we notice that a network is divided into 2 or 3 components. So network connectedness is very important, and network connectedness is related to nodes, because nodes some nodes may have crucial rules in making a network to be connected. And these nodes, if they are deleted or omitted from the network will be disconnected. From network components, we also discussed giant components, and then we discussed the closure rule and the triadic closure. We discussed also clustering coefficient, and then we studied the social implications or applications of this triadic closure rule. And we say that many social applications of triadic closure rule exist in society, because, for example, if we have 3 people, A, B, and C, and if A is a common friend of B and C, then even if B and C now don't know each other, they are most likely they will be friends in the future, because both of them has a mutual friend who is A. We studied this notion of triadic closure, or closing the triangles between friends, and we studied also its social applications. And we ended we ended lecture 8 with another concept, which is bridges and local bridges, and we also studied the social implications or applications of these bridges. In lecture 9, we studied another part of network properties, which is strong and weak ties. We discussed the concept of strong and weak ties, and based on the strong and weak ties, we also discussed the concept of strong triadic closure, or we redefined the triadic closure that we have studied in lecture 8. We redefined them in lecture 9 in the terms of strong and weak ties. And then we studied social applications of strong and weak ties. We studied Marlowe's experiment concerning tie strengths on Facebook, which resulted in 3 categories of links or ties: mutual communication, which was the strongest tie, one-way communication, and passive engagement, which was the most weak tie in the network of Facebook. We also studied nodes positioning and the structural equivalence, which is a very important concept also in network analysis. And we said that structural equivalence, in order to occur, there must be 2 conditions to be satisfied. The first condition is similarity, which means that both nodes are similar in the structure or in their pattern of relationships. And the second condition is proximity, which means that both nodes are connected to exactly the same nodes. And then we studied 3 social applications and 3 social implications of structural equivalence. We studied that structural equivalence may give me a very important hint and notice on the status or social roles inside social systems. It also gives me a notion about power and how power is distributed among agents or actors in a real social network. And the third social application of structural equivalence is social homogeneity, because structural equivalence give me a notion about how homogeneous this society is. After social implications of structural equivalence, we also studied structural holes, and we said that some nodes act as gatekeeping to prevent structural holes to occur inside a social network. And we ended lecture 9 by studying link embeddedness and its social implications, including the trust and integrity of society. In lecture 10, we continued to study network properties as well, but in lecture 10 we studied two very important concepts. We studied homophily principle, and then we studied the associations of this homophily principle. And homophily principle means that people tend to interact more with people who are more like them or who resembles them. And then from homophily principle, we studied another concept, another relation, which is affiliation networks, because in affiliation networks, we have two modes or two different types of nodes. For example, people and affiliations, sporting clubs, interests, um, social clubs, and so on. Political parties, for example. So affiliation network also gives me an impact of homophily principle, because people who are interested in the same activity are all related to the same activity in affiliation networks, for example. So homophily principle with affiliation networks, both of them gives me an implication or a very important social implication about the uh, type or structure of relationships inside a real society. And in order to study the social application of homophily principle and affiliation networks in a social network analysis context, we studied a very important model in social computing, which is the segregation model introduced by Schelling. And in the segregation model, we see how affiliation networks and how the principle both interact together. After this detailed review for what we have covered or what we have studied in our social network analysis course during the previous 10 lectures, we are now moving on to a very interesting lecture, which is lecture 11. Lecture 11 discusses the concept of information diffusion in social networks. And in this lecture, we will use or reuse most of the concepts that we have studied in the previous 10 lectures. As you have seen in the previous two slides, we made like a brief review about what we have covered in each lecture, and you will notice that in each lecture we have both. We had studied some concepts, and then we apply or study the social application and social implication of this concept in real networks or in real social systems. However, in lecture 11 today, we will apply nearly most of the concepts that we have studied in the previous 10 lectures in order to understand how information diffuse in real social network. This lecture will cover four main topics. The first topic is the main concept of information diffusion. We will understand what do we mean by information diffusion in social networks and in real social networks, which is in society. And then we will move to the second topic, which is the reasons behind this information diffusion, why information diffuse. And then we will move to the third topic, Is information diffusion related to network analysis that we have studied or not? So we will see how diffusion will be represented as just a network phenomena. It's all about networks. And then in the final topic, we will start to discuss network structure and its relationship to information diffusion. Can network structure affect information diffusion or not? This is what we will study in the fourth topic today, and in this topic we will study two theories in social network analysis that are very important in studying information diffusion, which are small world networks and the theory of strength of weak ties. The concept of information diffusion is very important and interesting concept as well, because diffusion is very important for new innovations or ideas to spread. It's not only information diffusion, by the way. The diffusion happen for any idea, and you may notice that through your friendship networks, for example, or through your local societies, you will find ideas spread and they are contagion. So diffusion of new innovations and ideas spread through society, but spread through societies how? They spread through societies by means of interaction and communication. The way information diffuses or new ideas and innovation diffuses through a society is changing, as the ways in which a society interacts and to communicates changes. So if the society changes its way and mode of communication, we expect that information diffusion will also change. So our ability to understand this change is very important, as it is through the diffusion of information that members of society learn about the world around them. And organizations that are able to leverage information are in a position to grow both economically, socially, and politically as well, if they are political organizations. So the dynamics of information diffusion, or the dynamics of diffusion through social networks, is very important concept and very interesting to be studied. As we see in this shape in the slide, we can say that in information diffusion we have four main components. We have people or actors, which represent nodes in our social networks, and we have a content. This content may be an idea, it may be a new fashion, it may be a new innovation, it may be a gossip, it may be anything. So any type of content or any type of message transfer through or transfer from one actor to another. So we have actors in blue, and these actors represent people in society, and in the network context we say that they represent the nodes of our network, and we have a message or a content that will spread from one person to another or from one actor to another. But in order for this content to spread from one actor to another, it needs both. It needs a network and it needs a diffusion mechanism. It needs a network because if people are not connected together, then this message will not be transferred from one person to another. If you don't communicate with any other person, so you will not be able to deliver your message to anybody. And if you are communicating with three or four persons, then you will be able to deliver this message to the people who are located in your social network. So in order for diffusion to happen, we need actors, we need people, we need to be there to be a content or a message that will be delivered from one person to another. We also need a network of interactions or a social network, and through these networks the diffusion process will happen from one individual to another, transferring this message or diffusing this idea. In the previous slide, we studied how information diffusion or how ideas diffuse in a society and spread in a society through moving on from one person to another. So we studied how networks or social networks are crucial for information to diffuse. But why information diffuse? Why ideas need to diffuse? And why ideas diffuse and spread inside a society? There are several reasons behind why information diffuse or why the information diffusion happens. These reasons include, and not limited to, but they include the most or the main three reasons, which are the following. The first reason is information cascades. What do we mean by information cascades? This occurs when people sequentially copy information or ideas from one another, with later people infer what the earlier people know, thus imitating the behavior of others. And imitations are not mindless. When you imitate your friend, for example, in the way he or she dresses, when you imitate him or when you imitate her, it's a way to complete the lack of information. It's a way to know what earlier people or to infer what earlier people have known. So information tend to be cascaded from one person to another, either by imitation, which is not mindless, by the way, and or it's not just imitation. Sometimes people not only try to imitate just to imitate, people try to infer information that other people know. So information tend to be cascaded from one person to another. This is on the person level or on the individual level. But there is another reason or a second reason on the social or on the society level. Sometimes there is social pressure. What's the meaning of social pressure? People may adopt an idea or a certain type of action only because the majority of surrounding people are adopting this idea or this type of action. And sometimes the society exerts some sort of pressure on people to conform to the norms followed by most people in this society. So the society exerts pressure or some sort of pressure on people in order to conform to its norms. And in this case, norms spread inside a society. So, in the first reason, ideas, informations, type of actions, fashion, anything spread from one person or is cascaded from one person to another because people tend to know. They want to know more, so they ask the people who were before them, or people tend to be look like this person, so they tend to imitate this person. So in the first reason, it's the people's tendency or the individual tendency to imitate and to infer the knowledge of another person. So information cascades. This is one reason. But in the second reason, the society exerts a sort of pressure on people or on this individual in order to conform to what the overall society sees as the good thing or the right thing or the correct thing. And if people do not conform to these norms, they be viewed as deviant, and their behavior will be considered as a deviant behavior in the society. So in this case, the person will not be accepted as a member in this society. There is a third reason as well. In addition to the first two reasons, there is a third reason, which is direct benefit. One may want to imitate the behavior of others, not because he wants to infer knowledge from another person, and not because the society exerts a pressure on this person in order to imitate the behavior of the other, but one may want to imitate the behavior of another one if there is a direct benefit that may occur to him or to her when he aligns his or her behavior to other behavior. For example, the actions of others that will be affecting my payoff directly will be most applied by me. I will apply the actions that I view or I consider to be beneficial to me. For example, a company may apply a specific technology if this technology is perceived by the company as having a great benefit to this company. Diffusion, as it relates to social network and as we studied in the previous slides, is all about exchange. In order for an idea to diffuse or spread among the society, it's all about exchanging this idea between individuals constituting this society. And if we review literature of diffusion research, we will see that the diffusion research usually takes one of two paths. Some research or the first path of diffusion research is about adoption, and the second path to diffusion research is about network structure model. What's the difference between these two paths? We will discuss this now. In adoption, literature is or research is interested in addressing diffusion as an exchange that happens between two individual members, and it stresses the point how members interact in order for diffusion to happen. For example, how a member adopts the idea of another member through the communication between these two members of society. So in the adoption path of diffusion research, the stress is on how these nodes or these members interact, and in the terms of social network analysis, how these nodes are connected, how two or three nodes are connected, and how one node or one actor adopt the idea of another actor. However, in the second path, in the network structure models, diffusion is an outcome, not an outcome of adoption between separate members or individual members, but diffusion in this path is seen as an outcome of all member exchanges inside the society. It's based on the network structure as a whole. So adoption views the action of an individual as the driving force, while network structure research takes a global view, focusing on all the interactions inside this network. If we reconsider these two paths from the point of view of social network analysis and from what you have studied in the previous 10 lectures, you will reach a conclusion that both paths in research of diffusion can view diffusion as a network phenomenon. We studied in the previous 10 lectures that there are some properties that are very important, and these properties are on the global level of the network, and we call these properties network properties, like network size, network connectedness, network clustering. All these network components, all these concepts are properties of networks. So if you take these properties into consideration, and if you try to study the network structure as a whole and how this network structure affects the diffusion of an idea or the diffusion of a new innovation, then you are viewing diffusion as a network phenomenon. And you also studied in the previous 10 lectures that not only general network properties are of our interest in this course or in social network analysis, but also social network analysis is about studying the properties of nodes. And we studied, for example, the centrality, node centrality, which nodes in the system are the most central nodes or the most important nodes, who are the role models in this system, who are, or in this network, who are the nodes that most people are connected to, who are the nodes that connect two different components or two separated components of a network, and so on. So when we take the path of adoption, the adoption path of research focuses on the properties of nodes and the properties of edges, or the relationships or the ties or the social connections connecting these nodes together. So if we take the adoption path, we will depend on, or we will build the ideas of diffusion on the nodes properties and the edges properties, and we will relate nodes and edges properties to the speed in which a specific idea is diffused or adopted by many members of the society. And if also we take the second path, we will relate the spread of an idea or the diffusion of an idea with the network structure and the overall properties of this network. And we will say that diffusion depends also on network structure. So in both cases, we can view diffusion as a network phenomenon. For any further question or for more communication, please don't be hesitated to contact me on my email on the screen now. And you can also view these lectures on my YouTube channel or the YouTube channel of Cairo University as well. So, waiting forward to hear from you soon. Thanks.